All right. Thank you all for joining us. Good afternoon, and welcome to our webinar on city climate solutions. My name is Mateusz Martincic. I'm the head of marketing here at Senzemo, and it's my absolute pleasure to be your host for today. I know people are going to join more in a couple of minutes, but yeah, I'm going to make a brief intro. Please do book into the chat and let us know where you're from and what you're most interested in hearing from about today. I know this is a really hot topic for many of our clients, and it makes sense to dive into it more as thousands and thousands of cities in the world are having urban heat, and it's a big issue for many. Please let us know if there are any issues with the connectivity. And just before we start, I have to let you know that today's webinar is also going to be recorded, and the recording will be shared with all the participants afterwards. Today, we're going to talk about city climate solutions as urban heat is becoming a widespread issue. And let me give you a quick overview of the agenda as we get started. We're going to begin with a quick intro on why heat is an issue and it's important to address it. And it's going to be presented by Luca Mali, our CTO of Senzemo. We will then dive into practical cases from Slovenian town of Celje and its Prešernova Street heat level adaptation with urbanist Zala Velkavrh from Prostorož. And smart park heat management in town of Cary in North Carolina. Ted Urbaniak, IoT manager in town of Cary, and digitalization. Then we go to Germany, city of Coburg, presented by Andreas Kuker, digitalization manager at Subdacor. After that, we will have a look at our unique product that we just, put out into the market with our partner Meteo Blue. So Senzemo, our preference is IoT sensors, and Meteo Blue, a meteorology-driven company that provides forecasts and satellite image models for this exact issue. We will also welcome here Nico Bader, who will give the insights on this product from the Meteo Blue perspective. What our goal today really is to bring ideas on how to mitigate and measure urban heat and what we can do to visualize it and then adapt to it. And without further ado, I'm going to give my word to Luca to give us a brief intro on this topic of understanding the importance of heat islands. Luca is Chief Technical Officer here at Senzemo, but also a lecturer at the University of Ljubljana for electrical engineering. And he spent over 2 decades building real-world IoT systems in a number of companies and helped scale their operations. So if you let me, I'll just go here. All right. Go ahead, Luca.
Okay, Mateusz, thank you for the introduction. As you know, it's becoming very, very clear, of course, that the summer heat in our cities is getting harder and harder to tolerate. Of course, there are many factors that contribute to this trend, but at the core, I believe that, and we believe, of course, that our cities were never built for the climate conditions we experience today. So urban heat islands, of course, amplify health risks, drive up energy use, worsen climate impact, and of course, reduce biodiversity as well. So this is not an abstract concept anymore. It's a measurable problem that appears at the street level and demands our prompt actions. So the encouraging part in all this is that the issue is manageable. With reliable sensing and modeling, we can today pinpoint temperature hotspots block by block in the cities. And this allows cities to deploy, for example, shading, reflective surface, of course, and the greening infrastructure precisely where they will deliver, of course, the greatest benefit. So we know that the heat has become a costly and dangerous budget item. So during heat waves, each additional degree Celsius raises electricity consumption by up to 2%, pushing up peak prices and increasing, of course, the risk of outages. At the same time, more importantly, mortality rises up to 5%. So for each degree Celsius, there is like the mortality rises up to 5%. And of course, some groups are even more affected by that. The most effective response is precise measurement and targeted intervention, adding a set shade, a cool surface, or even trees, exactly where they will deliver the greatest energy saving and, of course, health benefits. So in the cities, extreme heat events have increased significantly by 4 times over the past 5 decades. The reasons are familiar: denser development, limited tree cover, and expanding building surface. So the urbanization, of course, continues, and these events grow hotter, more frequent, and longer lasting. The response must be both urgent and precise. So measuring heat at street level, pinpointing the most exposed areas, and focus interventions where they achieve the greatest impact per euro. So cities are, of course, eager to respond. We know that we talk to many municipalities and mayors, yet they constantly encounter three obstacles: limiting sensing coverage, uncertainty, and interpreting the data, and the belief that complete solutions are too expensive. So these challenges have to be addressed directly, and we can offer IoT systems that are simple to deploy, cost-effective, and ready to support informed decisions from the outset. And this is why we're here today.
All right. Thank you, Luca. We will get to different ways of measuring later, but now let's focus on practical cases where urban heat adaptation strategies have been taken recently. So first is Zala Vilkavar. Zala and her team have taken on many heat-related urban projects in the past, and she works for an urban design studio called Prostorož here in Slovenia. She will talk about the recent adaptation of a street in the city of Celje called Prešernova Street. So please, Zala, take over.
Thank you, Mateusz, and thank you for the invitation. I will briefly present one of the recent cases that we've worked on. What you see on the picture here is Celje, a city of 40,000 inhabitants. So maybe we will start this webinar with small cases and move on to bigger cities later. And you can also already change the slide. Thank you. So what you see on these three images is Prešernova Street. This is one of the main historic streets in Celje. Despite the fact that this is the main connection between the city center, the train station, Old Town, and several administrative and educational buildings, a part of the street that you see on the photos is still quite degraded, with legal and illegal parking taking most of the street space, despite being surrounded by quite beautiful historic buildings. As it's also quite visible on these photos that the street has no natural shade or trees. And in 2025, the municipality of Celje finally decided to renovate the street. And Prostorož, the nonprofit urban design studio I'm part of, was commissioned to conduct studies on the street and off the street to kind of assess the current issues and evaluate the potential for improvement. And we can move on to next slide. We have conducted several different studies and analysis from analyzing problematic traffic situations to pedestrian count, showing that 10 people move on the street on foot every minute already, which is quite a lot. We also did surveys with passersby, and behavior observation and survey results already showed that the northern side of the street is quite exposed to sun, that it's problematic due to this exposure, that fewer pedestrians walk on the northern side, and that also there's very little shade available. And with the help of Sensimo's sensors, we can move to the next slide. Yeah, with the help of the sensors, we were also able to track air temperature on the street throughout the summer of 2025. These data that you see on the photos are morning temperatures, but you can already see 1 degree difference between the northern and the southern side of the street, showing quite big differences between the sunny and shady sides. And all these measurements were important evidence for us, but also for the municipality of Celje, because we were able to quantify the issue of urban heat wave, extreme heat, and prove that the street basically needs to change if it's to attract residents and visitors alike. Targeted measurements to cool the street down were obviously necessary. And finally, what I can already show you is the visualization of the concept plan done by Slovenian architecture studio Krušec Arhitektura. The concept design, which was approved by the city council and the residents as well, features a unified paving that you see on the render, features large planters for trees on both sides of the street, but also a lot of benches and spaces to linger. Based on temperature and other measurements that we did, we were able to argue for a street that is a shared space for pedestrians, cyclists, and that has very limited number of cars. But we were also able to ensure pleasant greenery on both sides of the street, therefore cooling the temperatures during hot summer months that we are anticipating. Thank you.
All right. Thank you, Zala. This was very insightful, and I really hope we can. I think there's going to be another round of measuring right after the project to just confirm all the changes that were made. So it's great to hear.
Right after the project, and also 5 years later when the trees are able to grow a little bit.
Yeah, perfect. Nice. Okay, so now we're going to continue and we'll move to the US for Town of Cary project. So Ted Urbaniak, who is an IoT project manager in the Town of Cary, North Carolina, has been overlooking the project in terms of IoT for the downtown park of Cary. It's a unique 7-acre state-of-the-art play space for all ages, opened in the heart of downtown Cary last year. And from walks on the elevated skywalk, playgrounds, performing arts pavilion, fire pits, a sports lawn, dog parks, it offers a lot to park visitors. So the municipality also wanted to make the park smart and in the way that it would alert visitors in case of extreme heat. And yeah, I'll give my word to you, Ted.
Thank you. Thank you so much. Thank you for having me here as well. So yeah, so the town of Cary in North Carolina is a very unique place. We're very forward thinking when it comes to technology. A lot of our council members are worked in the tech field. So when we come up with an idea, they understand that data is king and that we should be collecting data so that we can make data-driven decisions and try to take the feelings out of decision making and being like, I feel like we should do this. No, here's the data. Let's see what we can do with this, and your answers will come out from there. Go ahead and change the next slide, please. So yeah, so the downtown park is a very unique place. It's actually a 7-acre park. And so in this park, we actually have Wi-Fi for park staff and the public. Just to have Wi-Fi throughout the park from corner to corner, we actually need 41 access points. So with 41 access points to be able to cover 7 acres of the park, I have one Laurel Wan gateway on the 7th story of the parking garage building that's actually blanketing pretty much the whole downtown area. So 41 access points for Wi-Fi, one gateway that's actually talking to 300 sensors in the downtown park. And the sensors that we have in the park are obviously temperature sensors. I put the Sensimo temperature sensors in 8 strategic locations in the downtown park so that we can cover heat mapping. So we can also figure out microclimates as well. We have a 7-time daytime Emmy winner that is a horticulturalist who was actually working for a university in South Carolina, and he was on a TV show talking about plants and how they should grow, and he was just winning Emmys back to back to back. So he's actually on our team for the town of Cary, and so I'm working with him now to figure out microclimates, to where's the best place to actually put trees and shrubs. Because on the 7 acres, we actually have 70,000 species of plants in this area. So it's a really great location for a destiny or destination, I'm sorry. And then, of course, we are monitoring trash cans at the park. There's 60 trash cans that we're using LiDAR for. We've got smart restrooms in the park as well, to where we're monitoring paper towels with LiDAR. We're monitoring the doors as well, and of course PIR sensors to make sure lights are off and stuff like that. Go ahead and switch to the next slide, please. And then, of course, this is what we're doing with the dashboard. We're providing a dashboard to the park staff. This is where they can actually use data for their decisions. So if they are going to have an event going on, is it extremely hot? Do we need to provide some more drinks out there for park staff? Is it extremely cold, being that we need to actually throw down some salt on the sidewalks? Instead of looking at the news, which is actually taking data from, let's say, the airport that's 20 minutes away, I'm actually giving faculty and staff what they need at that location. This is what it is at the park. This is your weather and stuff like that. So if I can actually show my screen, I'll show you some other things.
Yes, of course.
Bore you a little bit. And so this is, if everybody can see my screen, I hope. This is actually the microclimate dashboard that we have for the downtown park. The downtown park is all right here. It's 7 acres. And actually, just to add more to the confusion, the downtown park is actually a social district as well too for the town of Cary. So you can actually come to this park and grab a beer, have a drink, walk around, and then also too, we've expanded it to other restaurants. So you can actually walk down the street with a beer in hand and a special cup and actually enjoy yourself a little bit more. So we're definitely trying to be more forward thinking. But when you hover over these different locations, you can actually see on the map where the line will actually show you each. And so the horticulturalist can come in and actually see if this location is actually perfect to where they need to plant stuff. And then, of course, show you some other things too. We do have the trash can bin maintenance as well, which is using LiDAR too. And we do get temperatures from all of the trash cans. So we can actually see that a 80-degree day Fahrenheit can actually make the trash cans up to like 110 degrees Fahrenheit and be kind of hot to touch. So of course, just wanted to share that with you. Other things that we are doing is I'm partnering with a facility called USA Baseball. USA Baseball is a training facility that this guy right here is actually a multi-million-dollar facility, which here's the picture on the inside. It's an old Google picture, but this one's actually done. And so if you look here, all the walls are actually open. So it was a cold day when we were walking around. We're actually going to put a temperature sensor in here because during the summers, it's really unbearably hot. And if we start monitoring the temperature in these fields, we can let players know when they're in extreme heat. Also, we can let the facilities know when's the best time to rent this facility. Is it early morning? Is it late afternoon? Cloudy days, stuff like that. And of course, this facility has it has 2 fields that are actually grass. The other 2 fields right here are actually artificial turf. And we've heard rumors that artificial turf actually heats up more than asphalt. And so the players in the outfield are actually burning their feet with their cleats and stuff standing out here because there's no shade. So we're going to stick some temperature sensors out here to monitor if that's true. We're going to put some temperature sensors out here in the outfield to see if real grass actually does cut down on the heat. And then, of course, while we're doing that, we've got another baseball field that is close by, and we're going to do the same thing like we did at the park as well. And then we'll be able to give them data as well, and they can see what things are throughout the years and show when's the best time to actually have training camps, when is the best time to have competitions and stuff like that. So that's what the town of Cary is doing.
Nice. Yeah. I'm impressed, Ted, and we talked about how town of Cary has a lot of trees and how it's like one of the most advanced cities in these terms as far as gathering data and actually doing something more kind of European style in the US. And they also won multiple awards already for that. So great job. Okay, so, and now we're gonna turn our direction towards Germany, to the city of Coburg. Coburg also in the summer deals with high heat levels, and they decided to adopt a citywide network heat management solution. But before we start, Andreas, we're gonna play a video that we've actually recorded there. All right.
Der Klimawandel wird natürlich auch in der Stadt verstärkt spürbar. Das heißt, es wird heißer in der Stadt und die Stadt Coburg macht sich natürlich Gedanken, wie man diesen Effekten entgegenwirken kann. Und wenn wir dann eben in der Stadt Maßnahmen ergreifen, dann wollen wir natürlich auch schauen, welche Wirkung das entfaltet. Und da haben wir natürlich von vornherein auch an digitale Lösungen oder digitale Unterstützung gedacht.
On research projects, we usually take a role of technology providers. Currently, we are involved in a number of European projects focusing on agricultural, industrial and urban environments.
Natürlich geht es auch darum, in der Stadtplanung Werte zu generieren. Wo sind Hotspots? Wo ist es zum Beispiel im Sommer richtig heiß, wo man zukünftig mal schauen kann, ob man da was verbessert.
With our extensive experience in IoT and experimental methods, we are a perfect partner for universities and municipalities.
Die Sensoren funken regelmäßig ihre Daten drahtlos weiter und in der Region die Gateways empfangen die Informationen und leiten sie zu uns ins Rechenzentrum, wo dann die Darstellung auf einer interaktiven Karte erfolgt.
We're all about quality. Our sensors are all manufactured here in Slovenia using sustainable and quality materials. Our sensors last up to 10 years using single set of batteries and have unmatched accuracy.
Die Sensoren messen alle 10 Minuten die Lufttemperatur und die Luftfeuchtigkeit, um so einen guten Überblick über die klimatischen Verhältnisse der Stadt zu liefern.
Also wir sind sehr, sehr zufrieden, auch mit der Betreuung, die wir erfahren haben. Also für uns ist es ganz wichtig, dass wir auch einen Partner haben, der uns dabei begleitet, der uns dabei berät. Ja, das Endziel ist natürlich, dass unsere Innenstädte auch weiterhin lebenswert bleiben, dass also die Effekte des Klimawandels ein bisschen abgemildert werden können, dass Mikroklima in der Stadt für die Bürger weiterhin angenehm bleibt.
All right. So I give my word to Andreas.
Yes, hello to everyone. Thanks for the invitation. Yes, as you have seen in the video, Coburg, we have a historic city center with quite narrow alleys. And here the buildings often heat up in the summer and additionally warm surrounding the air. And due to the lack of air circulation, the heat islands with sometimes high temperatures are appearing. And in collaboration with the city administration, we identified 50 locations as points of interest to be monitored with Sensemo sensors. These points are distributed throughout the city center and provide an overview of the city's climate situation. Various locations were chosen for monitoring, for example, public squares, heavily frequented streets, parks for recreation as well, and green spaces near buildings. On an interactive online map, as you have seen, the citizens have a direct access to the measurements and can view the climate data of their city in nearly real time. But due to the general climate change, the conditions in the summer months are getting worse. Hotter temperatures in June, July, and August pose a danger, especially for young children and elderly people. To better protect them, microclimate and climate monitoring in the city aims to provide information about current temperatures, which places should be avoided because it's particularly too hot there, and where are the cooler places in the city that poses less risk. Furthermore, a dense network of measurement points aims to create a valuable database of temperature data to enable a long-term evaluation of local climatic changes. This will make the effects of climate change visible for the city and the citizens of Coburg. And when urban planning changes occur, such as concrete and sealed areas being renatured and greened, the impact can be demonstrated with measurement data by comparing historical data. The before and after comparison will clearly show the effectiveness of such construction measures. And the database created by regular measurements is crucial. It will provide the basis for future actions, allowing decisions to be made in the city based on objective facts. Smart data for a smart city. But the measurement data is not only displayed in real time on the city's website. Starting next year, there will be an app available for residents that provides personalized heat warnings. The citizens can register using their home address, and the system will identify the 3 nearest sensors within the network. If one of these sensors records a critical temperature, the system sends a warning to the resident. This alert can be delivered either via email or SMS. And additionally, we offer an autonomous display for key institutions as hospitals, nursing homes, kindergartens, and schools. This device shows the local temperature readings and automatically displays a warning if critical values are reached. It is battery powered and wirelessly controlled via LoRaWAN. So we try to get the most value out of the data for our residents and cross the border back from online into the real world and display the temperature measured by the Sensemo sensors.
Thank you, Andreas. Coburg is a really, really nice town, I would say, like typical European, but very forward thinking. And I see a lot of that now in Germany, especially with LoRaWAN. People are adopting more and more measures regarding heat as well. All right, so these were the practical cases, and now I'll give my word to Nico and Luca. It has come to our attention that there really is not a good wholesome solution on the market regarding the topic of city-wide urban heat solution. That would include both ground data and satellite data that offers better models for cities and urban planners to then adopt new strategies to handle heat. So Luca, maybe you can present now the new product.
Yes. So as you saw, of course, this is a huge problem, and many cities are dealing with it. And so, as already mentioned, we would like to actually present you our approach, and we call it City Climate. So this solution was developed by us at Sensemo, of course, in collaboration with certified meteorologists from Meteor. Nico will later present more details how is their approach to this. So, but the bottom line is that it brings together microclimate sensors we use in our case our SMC30 out. So basically the sensor you saw also in the video and on the photos that the town of Cary is using, the Coburg is using, and also city of Celia is using, and many other cities around the world. On the other hand, we are actually the sensor uses the LoRaWAN network that was already mentioned by Ted previously. And on the other hand, we're using the satellite data that is, of course, publicly available. And we're using the operational modeling to provide the end solution. So with continuous refinement, we actually enable us to do a real-time heat maps at roughly 10 by 10 meter resolution. And we actually, the system supports features like UHI alerts and short-term historical data. As already mentioned, there's the slides are moving or not?
Up, yeah.
Yeah, thank you.
Yeah.
So as already mentioned, the SMC30 is a proven LoRaWAN microclimate solution. We believe this is like the best choice currently on the market worldwide for measuring microclimate events, and is designed, of course, in Slovenia and manufactured in Slovenia and Europe. It measures air temperature, humidity, and also air pressure. By that, we can, of course, calculate different parameters like dew points, frost alerts, and other parameters, storm approaching, and so on. And we install it directly to the poles or facades using this handle. And it stands quite demanding outdoor conditions. So it's IP65 graded, and it has the UV stable housing that we're using, so the weather protected radiation shield. We power it by two off-the-shelf AAA batteries, and it offers multi-year autonomy. From the operational perspective, it supports NFC reconfiguration, over-the-air setup, and also offers temper alerts. So basically, it has movement sensor that can be used for that we actually know what's going on the site. And overall, actually, it enables fast deployment set and low OPEX, and of course, reliable street level data. Provides reliable street level data for real-time heat mapping. Mateusz, please, next slide. Yeah, thank you. So on the one hand, so on our left-hand side, Senstic microclimate SMC30 LoRaWAN microclimate sensor provides real-time street-level data. That then the observations are continuously integrated into the system with meteorological models to improve the accuracy, of course, across the whole city. And the results are quite clear, and we can take actionable measures. So basically, hotspots, priority areas, and then tailored recommendation for both current and future conditions. Last but not least, the citizens can receive the simple mobile insights with all the alerts, and of course, some groups are, of course, can get even more detailed views in the data. In this way, we actually can transform targeted urban heat adoption. So maybe now I would like to kindly ask Nico to, yeah, please.
Yeah, thank you, Luca. Yes, also hello from my side. I'm happy to be part of this webinar today, and also part of the collaboration with Sensemo. And yeah, so what we did at Meteo Blue a few years ago was we thought, okay, we want to change something from very static city climate analysis for cities. We want to go more into the direction of delivering digital solutions to cities, providing some real-time insights, but we always focused on both sides. So on the one hand side, on the long-term planning, so help cities on long-term planning, see where hotspots are, where to adapt to the occurring heat. And on the other hand side, also focus on the real-time aspect. So to give the information on the one hand side to the municipality, to civil protection, to show them, okay, what's currently happening in our city, so related to heat, but also showing this information to citizens today. So as we have seen in Coburg, you can see the sensors on a map, and our idea was to provide spatial consistent data, so a model data set, a grid where you can see on 10 by 10 meters all over the city how the current temperature in the city is behaving. And the best synergy is if you combine our model with existing measurement networks, as you can see here also in the map, and I will also show a real-time example in a few minutes. But the synergy is the best if you combine the model to get a spatial consistent data set, and with your local information, your high accurate information from sensors, that you can provide an even more accurate air temperature insight into the city. And if you go to the next slide, thanks, then you can see more the long-term planning, because on the one hand side, we have the short-term view on the city, so we can inform what's happening at the moment, what's happening also in the next days. So we can also provide a forecast for the next 7 days to see, okay, what's happening tomorrow. Maybe we have a heat wave alert from the National Weather Service, but I don't know, what does this mean for me and for my location? So I can react based on the data. But then on a long-term perspective, I have to see, okay, where are the locations in my city where we always have problems? So the hotspots in the city, and in these locations I have to act. I have to change something. And as we have seen the example in Celia, we also have it here in Basel, in our hometown. We had this example. You can see the two pictures before and after. So we had a sealed surface before, and then the municipality decided to de-seal the surface, put gravel there, plant 18 trees, and we measured at this location with different sensors before and after effects. So to see what's the microclimate before, what's the microclimate afterwards. And on the one hand side, this is verifying existing adaptation measures, but as you can see in the upper image, it's also modeling what could be possible. So to get your city as a model, and then see, okay, what's happening if we introduce like a pond, if we do a rooftop greening, a facade greening, if we implement trees on a spot, if we de-seal surfaces and greening surfaces. So to see on the one hand side before, where are our hotspots, where do we have to change something, what would be the best option to do, because we get the best model results, and then afterwards also verifying with sensors what's the before and after effect in our city. And this is then a very useful information for the municipality, because they can show to the citizens and also to the decision makers, okay, we did something for improving your for the local climate, for the citizens, and here's the measured result, so that we have a change from the last years until now. And if you go to the next slide, thank you, then you see the long-term benefits of this. So on the one hand side, you have the real-time application, you have the long-term perspective. So on the one hand side, we want to adapt to the climate change, so to a changing climate, but we also want to help for saving energy by lowering local temperatures. So you can reduce, you don't need or you need less time for working ACs. You improve the citizen comfort, because by planting trees, for example, you also increase the potential of shadows, so people can sit below the trees for getting So to have the improved thermal comfort on the human health. So we have different parts where we can improve on a long-term perspective the life in cities and to make cities more livable in the future. And with this, I quickly share my screen. Yeah, now you should see my screen. So our website, where you can see, we have different information about our urban, so we call them our urban heat maps, and you can see here a map where we currently have our model running. So at the moment we have more than 100 cities worldwide. I mean, you can see it's very focused on Europe. We have one in Africa, which is Cape Town, and one in Brazil, but it's very focused on Europe at the moment. But in principle, the system of combining sensors and the model is in principle available in every city worldwide. So it's not bounded to a specific area or whatever, or size of a city, so we can implement it wherever we want. And if we change now to our hometown here in Basel, then you can see how it looks like. So this website is not restricted to a specific group of people. It's freely available on our website, and then you see the different temperatures in the city from the sensors, and then you can change the time. So during autumn, winter, it's not that spectacular, but you can really see the urban heat island effect also during winter. And then you can see here the measurements. So our sensors in Basel also have precipitation, but you can see here the heat sensors. You can see the measured data, and you can look back 72 hours historic data until now. And if I quickly show you also our map in Zurich, where we also have a measurement network in the cities of Zurich. So there are around about 90 sensors, and they, on the one hand side, give information about the current climate. But as you can see here, we can also look into the future, what I mentioned before in the slide. So we can also show what's happening in the next days. And this is very important for the short-term extreme weather resilience. So to see what's happening the next days and provide this information to different departments. So for example, to the health department, provide this information to citizens in an app, on a website. And as we have seen, for example, in Coburg, also using this data, maybe from measurements, maybe from a model data set, and provide this information in as warning or alerting to the citizens, and inform them what's happening the next days, and give them some instructions what they could do for reducing the thermal stress. Yeah, thank you.
Thank you, Nico. All right, Luca, maybe just a little recap on why is this product a little bit unique on the market?
Thank you, Nico. So, of course, the benefits extend far beyond immediate relief. So the cooler cities, as mentioned, improve not just productivity, they reduce energy costs, enhance comfort, and contribute to the overall climate mitigation at the end. So taking action now delivers, of course, lasting operational and social return. So, of course, there is competition on the market. There are, of course, a lot of partial solutions, like we have it, like it's a Zimo, but partnering with Winter Blue, we provide City Climate the concrete solution that, compared to the expensive and partial solutions, offers a complete and cost-effective approach. From sensors to modeling and the end to action. So of course, this solution is backed by science, and as said already, 20 plus years experience in developing IoT technology, from development to, of course, mass production. And of course, Mateusz, can you next slide, please? And of course, we are not alone. We are developing this solution together with all of you. So all of our partners, cities, universities, and so on. So who help us actually to bring this solution to the market. Last but not least, of course, I would like all of you to invite you to join us on the mission to be the hit. So thank you very, very much, and please reach out if you need more info.
All right, so that concludes our session. Now it's time for you, listeners. So I'll give our word to you. If you have any questions, write it in the comments, or if anyone from the speakers would like to, in the panel of speakers, ask a question, feel free to do so. I have a few of those that constantly municipalities ask us, for instance, like, what is the best size in terms of number of sensors to deploy in a citywide solution? So maybe Luca and Nico, you can talk a little bit about that. But what's the network size that, what would be the best number of sensors?
Nico, please, can you start?
Yeah. So there's not one answer on this question, but it's an interesting question, and we had a bachelor thesis, so a bachelor student from the University of Freiburg in Germany at Meteo Blue, and he did the study for us and exactly investigating time in this topic. So how many stations you need to cover the urban climate in a very good way. And it depends for sure on the structure of the city, on the size of the city, but we did this study in cities like Zurich, Basel, also in Frankfurt in Germany, in Munich. So cities in the size of between 100,000 and more or less 1 million inhabitants. And the sweet spot of the stations are between, for this size, between 20 and 50 sensors, depending on the size. So in a larger city, maybe with a complex topography, you go more to the 50 sensors. If you have a very flat city, smaller city, then 20 sensors are enough. But there are some things you have to consider. But so there's not the one answer on this question, but this is a good number if you think about 20 to 50 sensors. So we are not talking about 100 sensors. So the example from Basel and Zurich I've shown to you is not a good example, because both of them are both of them started with a scientific project 6 years ago, where we had no idea about how many stations do you need to cover the urban climate in a good way. And based on our station data in these two cities, we started this bachelor thesis, and the outcome was, okay, it's way too much. You can also start with 20 to 50 stations. This is good depending on the size of the city.
Yeah, I agree with that, definitely. But again, there are, of course, special cases like Zala is now trying to solve, or we are trying to solve in the city of Celje, where we actually will put more sensors just on one street. Depends on the case, of course.
Yeah.
But as Nico said, it's not like thousands of sensors. So basically, it's kind of manageable by cities, and providing a lot of value.
Okay, we have a question from the audience from Peter Grundig. Is anybody already using MyOT LP van in order to drastically reduce the number of base stations needed? Maybe you, Luca.
Yeah, we of course are familiar with all the technologies, and we are also testing all of existing LP1 technologies and non-LP1 technologies. Of course, we are quite, let's say, we know all the technologies. But as already Ted mentioned, in their case, they're using only one LoRaWAN gateway for the 300 plus sensors in the one huge 7 hectare area. So LoRa is here. It's standard. It's working out of the box. It's interoperable. So basically, you have a lot of sensors available on the market, and kind of solving this solution. So we saw that adding gateways is in many times due to the redundancy. So basically, due to the network redundancy, not just to improve the coverage. So for 50 sensors in the city of Ljubljana, for example, we need like only 2-3 gateways, depends on the location. We of course add more just to improve, as said again, redundancy of the network.
All right. Okay, I don't see anything more here. I have a point that we also at Senzemo partner a lot with research institutes and universities. And for instance, like in a project with Celje, it was the rental of sensors that we did with Zala. So how was the deployment? And I mean, you practically need the data for just a certain amount of time, right, in order to prove.
We really wanted to gain additional evidence to see whether the, let's say, climate-proof renovation of the street is viable or not, or if it's even necessary. And after this, let's say, analysis phase, we don't need that many sensors on the street. But we're already working on new projects already, also in the city of Ljubljana, where I think we will use the same approach because we're working, I don't know, maybe Luca and Nico, you know the city a bit more. We'll be working with the University Medical Center, the hospital area, where we found out the, people who are vulnerable to heat risks are definitely there. So people with chronic illnesses, the elderly, babies at risk, and the area is also experiencing a big problem of overheating. We feel that microclimatic solutions are the only way to go, since it's quite a densely built up area. So we are looking forward to future collaborations, I hope.
Yeah, of course. I mean, yeah, it's always trying to go, towards where the data is needed. For instance, this product with City Climate, with Meteo Blue, we really focused on providing the value for municipalities in terms of pricing as well as a rental agreement. So for anyone who will be interested, we'll share the details after. If there's no more questions inside if there's anything you want to ask anyone from the panel, from the speakers. Zala.
Maybe I want to ask Luca and Nico another thing. I also have a few questions for Andreas, but we can discuss that later. I know that Meteo Blue made a model of the urban heat island for Ljubljana even before the Senzemo sensors were installed, right?
Yes, yeah.
And I'm wondering, how did this image change since the sensors are active? Like how much did the model needed to be corrected?
So unfortunately today we do not have the Senzemo sensors yet in our model, but yeah, so our model is also able to run without any sensor. So then we calibrate it based on existing land use data, building data, satellite data, and combining with our weather models. And but yeah, we did plenty of verification studies in the last years. So in our largest verification study, we included the measurement network data from 27 cities around the world. So with minimum 20 sensors, so the size depends a bit on the city, but with minimum 20 sensors, and we found out that including measurement data, we can lower the error of the modeling by 25 to 30%, so which is a lot. And then you will have an accuracy of the temperature below 1 degree Celsius with the model if you implement stations. And also the advantage of sensors, as we have seen in Coburg or in Kerry or in Celia, is you can have even more use cases. So use cases you cannot do with just a pure model. So on the one hand side, you can improve your model. With a model, you have the advantage that you have spatial consistent data. But on the other hand side, you can use sensors for tracking adaptation measures. You can see what is changing and what is the measured impact at the end. So you have a data-based result at the end. So this is also the advantage of a sensor. It's not just like improving the model, it's also giving more information at the end and opening new use cases.
Yeah, exactly. If I may, exactly. Yeah, and of course, more the frequency of measurements could be adapted like over the air, and when you need in a certain daytime, you can actually change the parameters and get more data, like frequent data. And just to be clear, in Ljubljana, we actually deployed the sensors. The Sensimo sensors were deployed before our collaboration with MeteoBlue, and we're still working, try to actually bring the MeteoBlue solution to Ljubljana as well. So actually to do what actually just Nico mentioned. Yeah.
Great, thank you.
Okay, anything else anyone has on their mind? If not,
maybe I have one question, if I may. The mitigation techniques, of course, we are looking, of course, and everybody's asking us as well that, and of course, planting trees and everything else. What are you actually doing, Andrea and Ted, currently on this perspective? Do you have any new approaches, or where are you currently by mitigating? Actually, how you actually try to lower the heat in the summer days?
So in case of sensors, there's nothing inside. We struggle a little bit with the people in the municipality who's in charge for these issues. So I tried several times to establish or to communicate the advantage of sensors in that field. But I know that some areas, some places in the next years will be put the concrete away and put more green into the city and try to reduce the heat. And that's at the moment in Coburg the thing.
Okay, thank you.
Yeah, so over by me, we have an abundance of trees. In fact, our citizens love trees, and they encourage people not to cut them down. And of course, even a little side note, in the downtown park, we actually have champion trees that are like over a couple 100 years old. And I've actually stuck a sensor on those trees to monitor the X and Y axes, so that if they tend to lean a little bit further than they need to be, we can actually, prune them, take them down if need be, and see that data. But we also celebrate Arbor Day in Cary, North Carolina, and we also give out native trees free to the citizens, and we do a lottery. It's like 5 trees. You pick your best one to the one that you're like, I really don't want it. And if you happen to win that tree, you literally just go up to the town of Cary campus, town hall, and give them your information. They give you a tree. They give you a coupon for fertilizer. They give you a little water gauge to put with the tree, and there you go. So I actually got a dogwood one year. And so what I'm trying to do is I tell people all the time with municipalities, especially with us, we're just as afraid as the citizens are of us, right? Because we're like, oh, what are they going to say? And then the citizens are like, oh, what are they doing? So that being said, I really can't tell people to like knock it off. You're making the ozone layer go away. It's going to be more, you know, heat's going up. But if I can document this heat, and if you're telling me that trees do lower temperature and we're giving out trees every year, well, then let me put up these sensors. Let me calculate this data. If we have things like citizen scientists, here, we have a thing called the open data portal. We stick all of our data on there just because we don't want you bothering us for the data. Why don't we put it somewhere where you can get APIs, you can ingest this stuff, and any school, any college, any high school, any elementary school that's teaching STEM, or this is what you want to prove, I can give you, now mind you, we don't have it now because we're working towards this, but I would like to give you 50 years of temperature data and tell me where are we going instead of looking at the polar ice caps that affect us but don't affect us, and like people are calling you liars. Okay, fine. Here's what's happening in your backyard. I can't lie about this data. There you go. Take a look at it. And that's all that I'm trying to do, is just let people know that data is out there and you can play with it. So, yeah.
Awesome. Very, very impressive. Thank you.
All right. Yeah, I think we're a little bit over time, but it was a nice talk, so I guess nobody minds. So yeah, I would like to thank all the speakers, all the attendees for joining us. I hope you gained more info on this topic and it gives you some ideas. If anyone's interested, like I said before, city climate product, please let us know and we'll refer to our Blage sales manager. Like I said in the beginning, we'll also share the recording of this webinar with you if you want to review it or send it to some colleagues. And yeah, thank you all again and see you next time.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Ciao.
Thank you.